It is my pleasure to introduce about Mr. Lasantha Seneviratne, a highly accomplished professional in the field of HVAC engineering and sustainable building technologies. Mr. Seneviratne completed his BTech Higher National Diploma in Mechanical Engineering with special studies in HVAC systems at the Advanced Technological Institute, Mattakulia. And later, he obtained his BEng in Mechanical Engineering from the University of Wolverhampton, UK. He has been an active member of American Society of Heating, Refrigerating and Air Conditioning Engineers, ASHRAE, since 2007 and currently serves as a board of governor of the ASHRAE Sri Lanka chapter. In addition, he also chairs the membership committee and serves as a co-chair of the technology transfer committee. In addition, he is a member of the American Society of Mechanical Engineers and associate member of the Institute of Incorporated Engineers, Sri Lanka. He is a volunteer member of the US Green Building Council and a certified Green Associate Professional of the Sri Lanka Green Building Council. About his career progression, he began his career in 2007 as a design engineer at Dangrove Private Limited, where he progressively advanced to lead the HVAC engineering department. He has been responsible for the design and construction of ventilation and daylighting systems for major commercial and industrial projects across the Sri Lanka and several other countries, including Bangladesh, India, Colombia, Pakistan, and Vietnam. In 2013, he joined Airflow Solutions Private Limited as engineering manager, overseeing project management, engineering operations, implementation, commissioning, customer services, and strategic planning. This is a key point of his life. In 2017, he founded the Air Control Group and currently serves as founder and managing director of Air Control Technologies Private Limited and Air Control Holding Private Limited, as well as CEO of Air Control Maldives Private Limited and Air Control Bangladesh. Through these companies, he provides engineered HVAC solutions in accordance with the international codes and standards, delivering turnkey projects for hospitals, hotels, schools, commercial buildings, and manufacturing facilities, both locally and internationally. So today we are privileged to learn from his extensive industry experience, leadership, and technological experiences in HVAC systems and sustainable building practices. So please join me in warmly welcoming Mr. Lasantha Seneviratne. It is over to you. Thank you.
Thank you, Doctor. Hope everyone hear me clearly. Is it?
Yes, you're audible.
Yeah, okay, fine. Thank you. Good morning. And good morning, all the students. I think that they all are in the third year students, or that
all are third year students.
Third years, and that means that they are have experience in the implant training as well.
Yes.
Okay, right, fine. Right. Good morning, all. So then, actually, today I will share that our today presentation. Is it okay?
Yes, we can see your screen.
Oh, fine, great. So then, okay, wait. Actually, thank you, Doctor, for inviting me for the this session. And basically today we are talking about the basic introduction of the HVAC systems, equipments, and industry practices as well. And this today we are not talking about the that deeply go with the that designing that some calculations and that kind of stuff, because you know that very well with how you have good academic stuff, and you learn more things with your lecturers, and same kind of that you can have that practices as well in your that self learning as well. So we are today our focus also give you for some introduction of the what kind of HEC equipments and systems you after you that completed your graduation, you become the industry. You came to the industry. You will find a job for the industry and what kind of opportunities you have, and then after the bigger role will start from your career to go through the industry with a professional engineer. So according to that case, you need to have some certain kind of knowledges of the what kind of equipments you can for the because that direction also after your graduation, you have a lot of directions in your engineering career. So then sometimes that some are going for the academic that path. Again with some university lecturers and that kind of path, and others are come to the industry. Then after you have that a lot of variations about that as a engineering practices. As a consultant engineering, as a contracting company, you can join for the consultancy firm. You can join with the contractors, some that kind of companies. And anyhow, you need to know about what kind of equipments and systems available with options for you in your that career path for the your engineering practices. That's the our focus for today lecture. And initially that I'm that you can see that my topics also I mentioned heating, ventilation, and air conditioning systems and equipment, and main that same time also refrigeration also in a part of the air conditioning. So then HVAC systems are categorized by the method used to procedure, deliver, and control heating, ventilation, and air conditioning in the conditions they are. That's the normally that what is if someone asking for the what is the HVAC systems, so then you can talk about it's a procedure to deliver and control the heating, ventilation, and air conditioning. That's the main part of the HVAC things. So then so then we are talking about this topic today, and what are the equipments and what kind of things you have, what are the problems, what are the case studies, what kind of problems you can find in the industry like this. So then are you that all the I think for 84 participants also there, are you like to go with all this lecture with 100% English or Singlish? What do you that prefer?
So we maybe have to go with English because there are several Tamil students who can't understand Sinhala.
Okay, right, fine. That's good. Okay, right. So then, first I need to know about you. I know that you have completed your first implant training. Am I correct?
Yes, sir.
Right. Can you that very quickly can one two student experience their knowledge about that what kind of that HVAC some sites and other kind of experience do you have? Anyone have for the HVAC site industry in implant training? your implant training? Are anyone joined with the HVAC company like that? A lot of companies in Sri Lanka to provide the HVAC systems and solutions for the industry. Sometimes either consultancy firm or contractor firm. Anyone join for that kind of places to complete their implant training? Like to go with that discussion like this lecture, because this is not actually that lecture. Maybe you know that lecture come to the lecture time, and they are talking and talking and talking. You are writing and writing and writing. So then we finish the lecture at that time and finish the session. I'm not like to do that kind of things. I need to for the like this lecture go with as a discussion. Actually, this is not the lecture. This is for the discussion part. I like to talk with you. So then, anyone have any experience or anyone not going for the HVAC industry, some sites or some that kind of things? It's okay. I need to know very shortly. That's it.
So during my internship period, I saw some chillers and those things, but I didn't engage with those things because I went there as automation.
You're joining as an automation part?
Yes. In
Okay,
HEMAS.
In HEMAS. HEMAS hospital project or?
No, sir. Consumer.
Oh, right. Consumer, right. Right. Anyone have any experience in that some projects or the ongoing some projects like that some commercial building, hospital, or any that kind of things? Okay, we will continue because we have limited time now. So then. Then basically, as a HVAC engineer, you know about this refrigeration cycle. This is that if you go for the domestic air conditioning system, light commercial air conditioning system, commercial air conditioning system, or industrial air conditioning system, all that air conditioning system, this is the heart, because this is the base of the air conditioning. So then I think all of you very well known about this basic refrigeration cycle and psychometric chart. So then psychometric and basic refrigeration cycle also the must. So then that's why I show this refrigeration cycle for my first slide. So then that refrigeration cycle, we can go both sides, like as low side and high side. High side also that because that four components mainly we have available with the refrigeration cycle. This that if you go with the compressor side, compressor, then condenser, then the expansion side, expansion valve, that kind of things. So then evaporator. Then evaporator, you can see in about that you are inside the building. If you have that your room have domestic air conditioning unit, split air conditioning unit, that's the indoor unit also the evaporator. And the condenser side, then compressor and condenser, you can find about the outside. In between that, expansion valve also there. So then this is the basic refrigeration cycle, and that these four persons they are that do the very they have that their own job to cool the system and give you better in air conditioning environment, to create you better environment air conditioning to these four people, evaporator, compressor, condenser, and expansion valve. They have their own jobs, right? So then I will not go for that deeply about the system, because I think you are the third year student and you know very well about the system, this basic cycle and psychometry. So then you need to follow the system and go very deeply for the system in your mind, because each and every places, if you go for the commercial, industrial, light commercial, or any kind of air conditioning system, definitely you need to know about this basic reference cycle and psychometric, right? That's why I mentioned this in here. So then, as an engineer, So then you need to know about what kind of things you need to, because you are doing a critical role in the air conditioning industry after you your graduation. If you come to the as a mechanical engineer to the site, because you know that initially that 10 years ago, maybe around 10, 15 years ago, each and every site they have that a lot of engineers like a civil engineer, again electrical engineer, again ELV engineer, again mechanical engineer, air conditioning engineer, like that, lot of engineers. But now world is a very limitations, and now they that kind of most of the jobs now vanish from the industry. So then you need to know, as a mechanical engineer, if you have a mechanical engineer, but you need to know about very good knowledge about the all that industry, like that mechanical things, the machines and instrumentations and other that kind of things. And the same times you need about the HVAC air conditioning, because that you know that all the buildings, more than 70% of the energy consumed from the air conditioning system. That's the normal thing. It's a like commercial, industrial anyway. 70% of the energy consumed from the air conditioning system. So then all the that projects that a very critical part for the air conditioning system. So then you as a mechanical engineer, you need to what kind of things you can do for the that reduce the energy of the building. What is the that because it's a very impact for the that global warming. You know that now we are discussing about the you can find the things that each and every professionals in world they are discussing about the global warming, decarbonization, like that of that kind of green buildings, like that kind of things. Also now you can there is a modern era. So then you know very well about that kind of things. So then you as an engineer, you have big role how to control the energy consumed in the system, and what are the design parameters, and how you as an engineer, how can you design the proper energy consumption, proper design for the air conditioning to building. So then you need to about that various systems and equipment and recommendations, one or more systems options that will meet the project goal and perform for the design intent. Occupant comfort. That means that I talk about the standard, what kind of standard you need to know about as engineer. That ASTRA also the one that professional body for the HVAC industry, and they have standard 55. They define as a occupant comfort, right? That also process heating, space heating, cooling, and ventilation criteria must be considered when selecting the optimum system, as well as the following. Right, that you need to take below items. How you need to some knowledge about the things, right? Right, like the temperature, humidity, how is the air motion, and air and water velocities, and water and water quality, and same as indoor and outdoor air quality, and how is purifications, and how can you purify the indoor and outdoor air, that most probably indoor air quality, how can maintain, and air changes, how many air changes you need to maintain about the building for the proper ventilation, and what is the acoustic and vibration parameters, because that's a very big role for the industry, because you know that if you have that design for the factory or any that commercial kind of building, so there's a big issue, because that environmental authority in Sri Lanka and all over the world, environmental authority, they have some that limitations for the acoustic characteristics for the building. So then your boundary line also they mention this is that 55 decibel you need to maintain in that daytime, and night time you need to maintain 45 decibel amperes, like this. That kind of things you have. So then you need to that knowledge, some limited knowledge about at least some basic knowledge or some limited knowledge about that kind of things. And what are the local climates? Because now world is open for the everyone. That a lot of Sri Lankans actually at the moment are now I'm doing this lecture in the Maldives, right? Now at the moment I'm in the Maldives. So then you need to know about like what are the climates of your that system implementation location, because you are working in the Sri Lankan company, but you have your site location maybe in another country. It can be Maldives, it can be that Bangladesh, it can be like India, it can be Maldives, it can be Vietnam, it can be USA, it can be Australia, because a lot of Sri Lankan companies have that from engineering professionals now. Companies are available in Sri Lanka, but they are served a lot of their systems and their implementations and their site location all the different countries, right? So then you need to what are the climates, because that climate zones definitely change according to the country location and that countries. I think you know that, right? So then you need to about your design parameters and other kind of things. As an engineer, you need to know about what are the climates about that zone, your site location. According to that climate, you need to do your designs and equipment selection according to that humidity, temperature, and that kind of that air qualities and everything. You need to know about the things and that modern mildew preventions like that kind of thing and the capacities of the that sometimes you have to that buildings. This existing building also they have for the expansion. So then future expansion and proposed expansion and future expansions both. That means that if you go for the example, you have that a mechanical engineer from some that company or that some consultancy firm or like that kind of place. You have to do the design. You have come to the design for you, and it's a it also has that you have that capacities that existing factory. If you think about this project is a Bangladesh, right? So this that factory they have 1,000 people in their plant at the moment. So they have expansion. They plan to propose expansion for another 300 people for accommodate for another expansion for the building. So then they have for the next 2 years, they have another expansion for the next another 300 people. So then after 2 years, they cannot again change all the equipment for their system. So then you need to know about the what is that your client or your customer expectation, what is his future plan. You need to talk about that as well, because that most of the engineers not doing for that part. They think about that also have the salesperson or sales people job. But as a design engineer, as a responsible engineer, you need to know about that kind of things, and you need to discuss about that as well with your client. So then you can get the correct idea. So then you can select the chiller or some that are 20%, 30% that are more for his future expansion. Because then he no need to replace 100% chiller to his future expansion, because that capacity you already accommodate for at the future expansion as well, and you can save a lot of monies. And redundancy. Redundancy is a very important part from the buildings. And at the same time that spatial requirements, that present and future, what are the requirements, that same kind of things I discuss about the things. And environment, health and safety. That's the very major critical role. What kind of that if you plan to install your equipment in that particular location in the site, so definitely you need to that 100% sure and guarantee for as an engineer, this equipment also not falling down. No, that it's in the future. It's like this. If you that install some unit in that nearly sea area like the Maldives or some that kind of place, so then definitely you need to think about if you install that four-story building outside the building, if you install that outdoor unit from the air conditioner, so then sometimes that maybe 6 months, 1 year, 1.5 years, according to that corrosions, that outdoor unit bracket can be damaged. So then unit 100% fallen down to the ground. So then that kind of incidents can be cause to the death of some people, no? So then you need to worry about that your equipment selection. What is the place you place that equipment installation places, and same time that is site location and that ongoing project ongoing time. What are the health and safety standards? That a lot of safety, health and safety standard you need to follow as an engineer. So then you need to about know about that kind of things. And same time the security and that cost. That first cost mean that how many, what is your cost, and at the same time the return of investment, because that client want to that install some system, then he worry about the how can I get the benefit of the system, and what is the time period I can recover about this investment. So then you need to know about the idea about that and energy consumption, because I initially also I told about that green building, how can we that reduce the energy cost and that carbon footprint, like that kind of topics now that very popular, and you need to select the you need to get the good energy that cost like that, and operator labor cost as well, and flexibility, controllability, replaceability, reliability of the unit, saves how is the service and what is the service time period, and what is the yearly maintenance cost and life cycle of the your selection units. According to that your unit selection, that your unit quality depend on the unit quality. Life cycle also that varies. If you get the unit from the India or that China and some European or American or like that part, that 100% that their quality also difference. So then life cycle also difference, and sustainability of the design and filtration. That filtration depends what kind of the things, and changing codes and standard. And the codes and standard, what are the codes and standard for the, because some that are more now that a green building also very popular, that for building there are some that are buyers. If you go for the garment industry, then buyers ask you for is a green platinum building, green gold building, like that. According to that kind of things, they can sell for the higher price for their product to buyers. So then that you need to about real about the what are the codes and standard you can use for these buildings like this. So then these factors is a very that very key points for the as a design engineer, as a maybe you are the operator of that building. You are not the design engineer about building, but you are the operator like this. You are the client side. After factory, you are the factory engineer. But you need to know about what is your equipment, what kind of things is available in this factory, what are the things, how can you reduce the power consumption with this equipments like this, and that maintenance, what is the maintenance frequency, like that, and that if you the builder and any kind of any role, any place, you need to know about these kind of things. That's why I mentioned these things in here. If you have any questions, you can ask, or you can send a message. So then after the Q&A session, we can discuss about that things. So then, what are the basic common equipment for the HVAC system? That's a very basic equipment. So what kind of things you can find in the industry? So the major point is a chillers. So then chiller is the bigger that the commercial or industrial buildings for the cooling systems, air conditioning system. Definitely you need to go means that light commercial, and that if you go for the supermarkets like Keels or that Cargill Keels like that, you can find the tower type air conditioner unit in the side of the inside of your that kind of premises. That's called that also connected to the ducting, and is the unit for that do the air conditioning part of that building. That's called the package type air conditioning units. And VRF systems and split type air conditioning. That VRF is a very light commercial centralized system that means that maybe high-rise building or office building like that kind of thing, the places. You don't need to go with each and every split ignition unit. You have outdoor unit separate. But VRF system is different. VRF one outdoor unit, we can accommodate 8-10 indoor units and different type of indoor units. That's also the called VRF systems and heating coil and heat pumps. That sometimes some applications you need to reduce the RH. You need to maintain the relative humidity. So then you need to go with the heating coils and heat pumps as well, and ventilation fans. And industry that if you go with some dust and fume extraction systems and like that kind of things, and kitchen, commercial kitchen, if you go that your project also for five-star hotel. So then they also have lot of areas like that guest area, their rooms area, and lobby area, again for the restaurant area, kitchen, laundry, lot of items. So then ventilation fans also the major role of all that places, because if you go for the kitchen, definitely you need to build a good environment in kitchen for their chef to work the good environment. Then you need to install ventilation fans to that area. And I will go through that what kind of things in the future slides. And same HVAC ducts and the humidifiers and dehumidifiers. That if you can control that high humidity area, you can or low humidity area, you can control the system with the humidifiers and dehumidifiers. And boilers and furnace, boilers and furnaces as well in part of the this place, this topic, and pumps and valves and air distribution equipment like that previous diffusers, dampers, like that kind of things, right? So then what are the chillers? Chillers also, is it that are you that very audible for my voice, so that speed also you need to reduce this speed, my presentation speed, because I need to talk about the case studies and that kind of things, what are the industry practice. That's why I am going for this item, these slides for the little past. Is it okay for you, or you need to reduce the speed?
No, sir, the speed is fine.
Okay. So then chillers. So then that main I told that a major equipment is a chiller for the industrial and commercial buildings. The chiller also we can define as a chiller for the basic three major components of the chiller. That it's a chiller type of the according to chiller type we can define like this. First is based on compressor used. That's a scroll compressor. That scroll compressor chiller mean that's 150 ton to up to 150 ton we can use for the scroll compressor chillers. And then more than that 150 ton to 500 ton up to 500 ton best practice also used with the screw compressor chillers. Then up to 400 ton for that longer chiller, like that 300 to that 1,000 2000 tonnage chillers, you can go with the reciprocating compressor chillers. And centrifugal as well. Centrifugal chillers you can up to 6,000 tonnage. TR mean ton. 1 ton equal for the 12,000 BTU per hour. So then that centrifugal chillers, centrifugal compressors, you can go up to 6,000 tonnage. In addition, our compressor can further be that type based on the dry used and construction compressor and driven. That is a hermetic and semi-hermetic. I think this kind of things I think come up with your lectures as well for your that academic. You have that what are the scroll compressors, what are the screw compressors, reciprocating and centrifugal compressors, what are the hermetic and semi-hermetic. Because so according to that case, I will not go deeply about that items. But you need to know about what kind of chillers. If you have that a very that supermarket kind of project, So then you can use with the scroll compressors because that it's that are very economical. Price also not higher, big that pricing and very you need to have that. According to that chiller, you can valves and other all the components, supporting components also very economical. But if you go to that like Columbus City Center or like that kind of big shopping mall or that kind of or 5-star hotel like that, definitely you're going to go for the centrifugal or reciprocating compressor chillers like that, right? And now also have magnetic bearing chillers and that kind of also things now available in the industry as well. So then what are the scroll compressor? I put some pictures to get the idea because you know that if you talking about the words more than you can get the identify about the pictures using for the features. This is the discussing about that four type of chillers compressors. These are the that things that is scroll compressor is that a very domestic air conditioners also. If you have your bedroom have some air conditioner or your home also some air conditioned units, you can find that it's called compressors. That's a very that domestic type air conditioned units, all and each and every unit, so that most of the people have their home have a refrigerator. So the refrigerator also have that scroll compressors as well. For the backside, you can find that compressor. So then screw compressor also have that this is the item for the screw compressor, and it's like a vehicle gearbox, right? So then it's have bearing, pinion gear, and a male rotor, air seal, visco seal, female rotor and male rotor. That are the screws. This is the compressor screws to refrigerator, and a bearing or timing gear, that cooling jacket, that kind of items also available in the screw compressors. So then this also the another compressor type, and reciprocating compressor also the different about that these two about two items. And at the same time the centrifugal compressor, centrifugal also centrifugal effect, or that also have the total different about that. This about three compressors and centrifugal compressors can go to 6,000 tonnage. You can accommodate with the centrifugal compressors for the 1 kilo, right? So then I told about initially 3 types. So then type 2 also chillers based on second major component. That means air cooled chiller or water cooled chiller, right? That air cooled chiller means that chiller also cooled outside part also cooled by air cooled. That means that condenser side it's cooled by air cooled, right? And water cooled chillers, they also have separate component called that cooling towers. So the cooling towers also doing the cooling part for the compressor side for the water cooled chillers, right? And third one is the absorption chillers. Absorption chiller is the source of the absorption chillers is heat provided by system hot water fuel burner. In absorption chillers, the compressor and water of the vapor compression cycle are replaced by two heat exchange, generator and absorber, and solution pump. It's absorption chillers. Actually, absorption chillers not using that our normal common practices for the industry. Absorption chillers, most of the absorption chillers are using for the nuclear power plant and like that kind of places. We are using for the absorption chillers, right? So then this is the some pictures of the air cooled chillers, water cooled chillers, and absorption chillers as well, right? So then another major part for the air conditioning system is air handling units. Air handling units means that if you get a chiller is his role also cool the system, cool the chill water to that you can supply the water system for the chiller And water system, you can find that the refrigeration cool that water. Then we call that a chilled water, right? Chilled water. So then chilled water come to the air handling unit, and air handling unit also that normal air for the ambient or that kind of air cool through that cooling coil. That cooling coil go for that chilled water. That's so then that cold air distributed to the your that required places. That the role for the air handling unit. And air handling units are designed to provide the function of moving air with the choice of facilities as required to achieve air mixing, air volume control, filtration, cooling, dehumidifying or heating, dehumidifying spaces, pressurization, energy recovery, and noise as well as vibration controls. That means if you want to that heated air, cooling air, some filtered air, if you go for the air, like it like this, that if you can design for the air handling unit for the factory building or that commercial that shopping mall or that clothing shop like that place. But that same air handling unit we cannot use for the hospital project, because hospital project you need to think about more about the filtration, because that hospital project also that entrance area, that reception area and common areas, you can use the one air handling unit type. And again, that same air handling unit you can use for the theater areas, operation theaters like that places, but you need to accommodate more filtration, like HEPA filters, bag filters, free filters, like that. So then air handling unit you can customize as according to your requirement like that. And basic component of the air handling units are supply fan motor, and water cooling coil, and direct expansion nutrition coil, and filters, mixing bowls, dampers, control system like that, right? This is the handling unit. I think some you have some experience, and sometimes you, according to implant training, you seen this kind of units. Sometimes so you have not seen this kind of unit, but after your graduation, you come to the industry. Definitely, each and every places you go for the your practicing time, you find it that these systems in that commercial and that industry buildings, and that are like hospital or supermarkets, factories, or any kind of places, right? And the handling unit also have that this supply ducting system, or return air ducting system, and mixing box, cooling coils, fans, like that kind of equipment, right? Then I told you that water cooled chillers need for the cooling towers to cool their that condenser site, right? So then cooling tower also cools that water by combination of the heat and very large water surfaces area to atmospheric air. This air is circulated by fans, connecting circuit currents, and natural wind currents, or induction effects from sprays. The thermal capability of any cooling tower may be defined by the following parameters, right? Entering and leaving water temperature. Definitely, as an engineer, you need to know about what are the entering and leaving air temperature for the cooling. And entering air wet bulb, sometime dry bulb as well, temperatures. And water flow rate. What is the water flow rate? According to water flow rate, you need to design about your water pump, because water pump need to distribute that throw that water to your particular point. So then you need to know about the water flow rate as well. So this is the cooling towers. So then I think that this kind of towers you can see about that because that cooling towers not used only for the chillers. Cooling towers using for the package air conditioning systems as well. So then you can find this kind of towers in that sometimes in that supermarkets, some that shopping malls, and that kind of places. You can see in this kind of towers, right? And you can see in that uh, 1, 2, 3, 4, 5, 6 cooling towers picture. That also for the nuclear power plant. Nuclear power plant also using for the cooling towers to doing the operations as well. And the HVAC ducting system. So you can see in this kind of duct for your that some industry practices and some implant training as well. This duct also, that role of the duct also, that air handling unit, we talk about the air handling unit initially, air handling unit, that a cold air won't distribute for the particular places, right? So then particular places you can distribute that things by used by that ducting system, right? So then that also have supply air duct, return air duct, sometimes that kitchen if you go for the dust generation, that's that tire manufacturing plant, that lost tire and other that kind of tire manufacturing plant, they have a lot of dust generations in the plants inside the plant. So then you need to design for the proper dust extraction system. So then you need to calculate the ducting extraction ducting, supply air ducting, like that kind of things. And air conditioning system, you know that have that moisture, you can that have that big issue for the moisture content of the surface of ducts. So then you need to go with the insulation for the insulated duct. And a duct type also have different type, square duct, oval type duct, spiral duct, round duct, and that fabric duct. You can see in this red color picture, that's a fabric duct, like that. Lot of duct also there. And as an engineer, you any kind of duct system, you need to know about that. What are the design methods? What are the velocities of the we can accommodate for the inside the duct? That it's like this duct designing method. Do you know how many duct designing method available in for the as a design? How many duct designing methods available? Do you have any idea? Hello, hello.
No, sir.
Right. So then you can go thoroughly about the designing that as a design engineer, you need in a your park drawing for the as a design engineer, you know about that kind of things as well. So then duct designing also have three duct designing methods for the world. If you work with the USA, if you work as a Australia, New Zealand, or that India, or Pakistan, that Bangladesh, Maldives, or Sri Lanka, any places, you have only three methods defined as a spec now. So then an ashtray. So then first is a equal friction method. That's a all the duct inside the duct surfaces we consider as a friction also equal. That's called equal friction method. And static region. That means all the static pressure that region by region static pressure also different static pressures we can maintain, and that called static region method. And velocity reduction. Velocity reduction also reduce the velocities by the each and every places like that way. That kind of things you can that size of the ducting you can do that design of the duct for your system. You need to know about that also as well. And you can find the systems, what are the equation method, what is the static region method, what is the other also that all the methods you can find for the for your if you interesting you can go for the lot of that things the designing things available in the that you can find in the through website because I that if I told you that a very interesting thing in the industry we can find now because I'm also have 3 4 at the moment also I'm normally for a year I'm have 3 4 interview panels I'm representing, so that a lot of engineers come to the after that their graduations they come to the interview for the job interviews. So then if you ask in some questions So they are what are this kind of things? What are this kind of things like this? So then most of the students now, new generations, they are told, sir, we have problem because we have not proper lecture. So we have not lecturer for that subject. Our module also that subject, that's correct, but we have not proper lecturer for that for lecturing to that subject. So then we have not about no we don't know about that things. But now we are in that 26th 2026, right? So then it is a modern era, right? Now you have to, if you have that your mobile phone, smart mobile, all the people have smart mobile phone and that laptop computers, a lot of laboratory facilities in your that university. So then you can go that places. You can find that your mobile phone, and you can do the self studies about that your lessons, right? Now world also changed like that. Now, if you go for that, because sometimes I'm visited in the USA. Last, I have one experience with the USA, one university for that 2024. So then, that most of the students they have no lecturers in that's some subjects that particular that a university not providing for the lecturers. So then they have self study uh, time slots in their academic that day by day academic timetable. So then that time, that syllabus also they are doing the self studies. They are improving their knowledge of the self studies. And again, they have that a senior badge student also. They also share about their knowledges with that time slot. So then you can find that a lot of that is studies also that is the modern study method. So then if we are Sri Lankans, we have good knowledge. If we go for the other countries, we have very smarter than other engineering professionals in other countries. But they are doing that kind of practicing methods they are now using. So then definitely as an engineer, you cannot talk about in the 2026, you cannot talk about we have not lecturer for that, like that kind of bullshits, right? So then definitely you need to do the self-studies, improve your self-study knowledge, right? So then that's why I told you that kind of things. If you don't know about that, what are the system method, the designing methods, like that kind of things. If you're interesting, you can go for the website. You can go for the that Wikipedia or any lot of resources, and you can find the things. Okay, and so then next slide is go for the grills, diffusers, filters, and dampers, right? So then this the that supporting equipments for the HVAC systems. So then if you go install the ducting, so then if you fresh air supply or ducting, you need to distribution that through ducting, and after distribution that particular room, particular lobby area, particular that area, that a final point also come for that this kind of grills, diffusers, dampers, like that kind of items. That so then that diffusers also grills and that supplier diffusers, they also have lot of items. Again, it's divided by that different name, that four-way diffusers, two-way diffusers, linear bar grills, double deflection grills, single deflection grills, strut diffusers, and that round diffusers, like lot of that varieties also there, and same also the extraction system that linear bar grills, egg red grills, and that like that kind of a lot of variations also there. And if you need to control the by that distribution of the ducting through air, so then you can use for the dampers. So then you can do dampers, VAV boxes, and that kind of thing. So then you can control the uh, how many how much volume you need to distribute that particular point. So then you need to control you install for the dampers as well. And sometimes you have fire hazardous. Sometimes that a fire dampers you need to motorize dampers. Sometimes you cannot control the manual dampers. So then definitely you can go with the motorized dampers as well. So then that some particular parameters that it automatically control there. At the same time also in the fire points you need to install the fire dampers as well. And at the same time I initially talk about that hospital case. If it is a operation theater, definitely you need to go with the big filtration system like the 99.9 HEPA filters and BAP filters, pocket filters, free filters like that. That kind of items you need to know about that kind of items as well. So then, what are the that lifetime of that filters? What kind of filters can be usable? What are the only one-time use? Like that kind of knowledge you need to know about the filtration system as well, because a lot of things it like this. If you that some hospital also have isolation rooms, so then isolation rooms they also have that isolation room means that some that it's like that a coronavirus it will spread for the others as well, no? So then coronavirus, that kind of virus, some person have available for that kind of virus, his hospital, that his room, we cannot that extraction about that supply adduct and extract adduct also there, and extraction air we cannot mix with the other that air handling to other place, because again it also go that a very critical case, because then if we mix in that thing with the uh, other that air handling unit, common air handling unit, then this virus also very easily spreading for the other areas as well. So then that kind of rooms we have special designs we need to, as a engineer practices we need to that supply we can supply, but extract point we need to go through filters and we need to disappear for the other system. At the same time, it also have we need to maintain the negative pressure from the that inside of that room, because that if you maintain positive pressure, again air through air leakages through those and other points, that again virus also go for the outsides. So then we need to maintain negative pressure of the that room. That kind of things we need to think about, and we need to be careful about as an engineer, because we have a lot of responsibilities about that kind of things, right? And again, ventilation fans. I'm talking about that ventilation fans in initial as well. The ventilation fans also have a lot of variations, that wall mounted fans, duct mounted fans, centrifugal fans, roof mounted fans, acoustic cabinet type, so that mean a low sound fans, at the same time that a bathroom exhaust fans, that a fresh air supply fans. Lot of variations available, and that according to the your that system design and your requirement, you need to knowledge about what are the suitable fan for this place. It's like this. If you that go with the dust extraction systems, so normally we can use for the centrifugal fan, right? But normally that extraction system we can use for the centrifugal fan. But it is a dust extraction system. Centrifugal fan you can use, but centrifugal fan also have blade type also different. It's a radial blade, forward curve blade, backward curve blade, like that. So then definitely dust extraction system you need to use for the backward curve blade, backward curve impeller. Otherwise, backward curve impellers, it not deposit dust through that impellers. It always throw out for the dust. But if you use for the forward curve blade for the dust extraction system, then forward curve blade duct particles accommodate and deposit for that blade. So then some certain time period, blade that impellers unbalance, and then you have create a big lot of problems, because unbalancing blade it come to through the that motor part. So then motor going for the damage, and again blades going for the damage, and extraction capacity also that reduce for the that time by time it's going for the reducing, like that kind of things can happening. So then you as an engineer, you need to have proper idea what kind of fans, ventilation fans, so suitable for according to your application, right? Again, that I talk about that package air conditioning system, VRF and split, multi-split, that kind of air conditioning system. But package air conditioning system, I told about this package air conditioning system have some pictures in there. The package air conditioning system also have floor mount, floor standing ducted type system, floor standing free blow type system, and ceiling mounted system as well. So the ceiling mounted system, we accommodate that package unit inside the ceiling, right? But a flow standing system, you can see in this kind of flow standing system like that. Very that common example is the supermarkets, like Cargill, Scales, that kind of supermarkets. They also have this kind of that air conditioning units. From the inside supermarket, you can see some corners or middle some that side walls. You can see in this kind of package air conditioner systems. And this also have that air cooled package and water cooled package as well. So that air cooled package, it unit also have outside, but water cooled package, again, the cooling tower also have outside, and package unit also available in inside, right? And VRF systems, I told about that VRF system we can use for the one outdoor unit, and it also can connect that more indoor units, one single outdoor unit, and that outdoor units also have that variable that VRF mean variable refrigerant flow according to your demand, according to your inside building demand, that automatically signal pass through the outdoor unit, and it automatically reduce that refrigerant flow according to your demand. That's the mechanism of VRF system. It's a called VRF and VRV as well. VRV means variable refrigerant volume. VRF means variable refrigerant flow. So then it's like that. If you that are designed for the VRF system for office building, so then office building also have conference room, managing director room, director's room, and sales department, accounts department, and a lot of that kind of that spaces, right? So then we have used for the VR system for this building. So then after 5:30 or some certain time period, that I have board meeting for the 6 to 8 p.m. Right? But other all the department now closing around 5 p.m. So then according to you, you need that accommodate for air conditioning only for that boardroom, right? So then that very VRF system that according to your demand, it automatically controlled by the outdoor unit, and that send the that control the flow rate and the things compression that capacity according to your demand. So it's that advantage of that is very you can get the very benefit for the energy, right? According to your demand, that energy also. Otherwise, that you don't need to that put the that energy meters or anything that because we are a system, it automatically reduce the energy according to demand. At same time, split air conditioners or multi-split air conditioners also have some certain that length, but split air conditioners good practices for the that are 100% capacity. If you want for the split air conditioner, it's like you know that split air conditioners, if you go for the your that house or other some that places for the installed split air conditioning unit, you asking about and you can see in that some advertisement of the air conditioning companies, 12,000 BTU unit, 18,000 unit, 24,000 unit, like that. So then that any kind of capacity, it depends on the your room size. But if 80, that unit also 24,000 BTU unit, it 24,000 BTU or otherwise 2 ton capacity, it produced by that indoor to outdoor length less than 5 meters, right? More than 5 meters, your capacity also reduce according to the length. But a VRF system, you can accommodate by the that long distance for the indoor and outdoor that length, you can go with a very long distance, right? So then that's the point for the VRF systems. So then kitchen ventilation system. Kitchen also the very that major part for the hotel industry, and the same time factories and other also places, because that the domestic also each and every house also have kitchen now, but most of the Sri Lankan kitchens we are not accommodate for the that extraction food door extraction system for the our houses, but the that commercial industrial buildings and that hospitals or that factories or that kind of premises, and again hotels, is a very big and major role for the kitchen, because if it's a five-star hotel may be five-star, but your kitchen operation also not continuing, so then definitely you need that hotel cannot operate. That hotel also need to close, right? So then kitchen ventilation is a very major. That a chef also the very that a key point of the hotel, calm and very that clear to good work environment according to his kitchen. Otherwise, he cannot work. So then, as an engineer, you need to maintain good environment for the kitchen inside the kitchen. So then, definitely, kitchen ventilation is a kitchen extraction system, particular some level of the fresh air systems and conditioned air system. And again, extraction system, you need to filtration, like you can use electricity precipitators, UV lights, and active carbon filters, like that kind of filtration systems, and lot of things you need to learn about the kitchen ventilation systems in industry. And same time hospital also have that kitchen for their staff and the people. And if you go for the factory also have again their own kitchen for their factory staff, factory workers to uh, serve for foods. So then kitchen ventilation is a very big role. Again, for the dust and fume extraction system and filtration system, if you go for the factory, so any kind of industry, it is a whole that a factory building, it's a hospital building, it's a that a commercial or shopping mall, like that kind of things, or it's a hotel or any places, definitely have dust and fumes, right? So then that according to the environmental that healthy conditions, and that's why that you know that each and every country have that environmental authority, right? Sri Lanka also have environmental authority. So then, if you go for the approval stage for the your factory building, no, if you're going for the factory building or that kind of that hotel or any kind of that a commercial or that industrial building facility, definitely you need to approval from the environmental authority. Then that people come to the place and they are looking what is your system, what is your planning, what kind of things you will plan to do the things, and what is the impact of the environment for your systems and your factory after install your factory or hotel or your commercial shopping mall or any that place. What are the impact after final result to the that environment? So then you need to very known about how you control the things like the dust, fume, and other that hot air or any kind of things. How can you control and fill other things? You have to options to filter this. That means that your inside building have machines, and that machines generate big sound. So then you cannot that sound go for the other land. No, your neighbor have to complain about he cannot come and wait their premises according to your factory building. That inside sound also come to their that place. Then definitely your factory have to cannot operate. So then what are the things, how you reduce the noise, how can you control the noise, what are the things, what are the materials you can use for the noise controlling. And the same thing about the dust and fume as well. So then you have your factory inside generate big dust particles, and that dust particles go to that environment or other neighbors. So then they have go to the complaint about that they have that dust particles and other kind of things. Then definitely environment also to come to your factory and they seal the factory. So then you need to that get idea about how you can control the things. And the fume are also the same, and what are the filtrations and the things. And you know that like that Toyota and Mercedes Benz, like that kind of workshops. They are vehicle maintenance workshops that inside the workshop also have that environmental safety and environmental that safety hazardous. Also, they need to maintain minimum safety levels about they are inside the technicians as well. So according to that case, they need to install that hose reel and that if you that if you your vehicle you go for the Toyota or that kind of workshop to that servicing purpose, then they are that after they are servicing that time they will that switch on the that your vehicle, and they have some testing for that. What are the what are the things about that engine works? So then a lot of that carbons and that gases come through your silencer, no? So then that come to the that working environment. So it hazardous for the other technicians. So then definitely you need to clean and filtration system to prevent that things. So then this you can find some one picture for here that in a top one corner with the hose fill system. So then you need to that hose connect to the silencer. Then after you can that switch the that vehicle and you can testing about according to that, right? That kind of things also available, and at the same time, that welding or welding workshop or that welding places, you have to generate the fumes, welding fumes, and that kind of things. So that you need to do that as well. You need to extract that as well. That kind of things you need to think about the systems, right? And then that is the actually that heating, ventilation, air conditioning systems and equipments. I'm talking about today lesson. That kind of things you have to meet about the industry, right? You have to work with this kind of equipments and systems in your future industry, right? So then, as an engineer, you need to know about the codes and standard. What are the codes? What are the standards as an engineering practices? As an engineer, you know about that your systems, right? The codes and standard represent the practices, methods or ratings, performance, requirement, and limits of HVAC and R, heating, ventilation, air conditioning, and refrigeration equipment, useful guides for the practicing engineers, right? So then this is a lot of that standards you can available in industry. One of the ASTRAE. ASTRAE is ASTRAE mean American Society of Heat and Air Conditioning Engineers. So then ASTRAE also the major part of the HVAC industry. They are the professional body to introduce all the world to what are the standards, what are the maintained standards, what is the psychometric charts, what are the designing stage you need to follow the that it's like this SSS 2.1 means it is a that Indoor quality. If you India quality, you need to maintain SSS 2.1. That's a standard. So like that. So then MCA also the that another standard is MACNA that if you doing the sheet metal ductwork you need to define as a is MACNA standard you need to follow. So then inspection standard, they define according to duct sizes, what are the sheet thicknesses, what are the sheet gauges, gauge 24, gauge 26, gauge 20, like that, 0.6 millimeter, 0.5 millimeter, 1 millimeter, 1.2 millimeter, your material size, what are the material thicknesses, what are the material coating thicknesses, like that kind of things. Standard also, LL is Magna and UL standard. UL means that if you're using for some projects, they definitely asking for the if you that this project, what are the UL standard you following? And ISO, I think ISO very known about and HRI and SA, ASTA, BSE that if you that use about that aircraft engineering that sometimes you can go for the aircraft engineering section that if you go join with the Sri Lankan Airlines or that airport aviation, you need to know about the SAE standards, standard for the aircraft engineering, right? එතකොට testing of that, say for the example, HVAC duct system, duct design is back in 2006. You need to follow for that definitely. And the testing of airplane installed environmental control system, that means SAE mean Standard for Aircraft Engineering, ARP 217D 1999, and revision also going for the 2016. You need to follow about that standard. So then you need to learn about that kind of standard. And ventilation acceptable indoor air quality of low-rise residential building, then definitely ANSI ASTRAE 62.2 2016. That kind of standard you need to, as an engineer, you cannot talk about the that as a layman level, no, that that a boss, right? You are not a boss or technician, no, you are as an engineer. So then you need to talk about the proper way. I'm using for my design this is standard. I'm following for these codes. I'm following for my design based on according to this code. This is standard. Like that. You need to talk about like that way. So then according to that case, you need to get the knowledge of what are the standards you need to follow. And this kind of most of the publications you can find about you can write down these websites like www.global.ihs.com. That means global engineering documents you can find about that. And tech sheets you can find about www.techsheet.com or www.astray.org. You can find about the Astray standard also. You can find, but Astray also you need to get the using their library, online library or online publications. You need to get the Astray student membership. You can get the Astray online that Astray student membership, and you can continue your membership as well in the all over the engineering life. You can continue that membership as well, and same times you can get the ASME membership that if you want to go for the green building side, you need to follow the green building exams. You can then after you can complete the exams, you can get the green building memberships like that. So then that kind of things also you need to think about for your future career as an environmental engineer, as a mechanical engineer, as a case engineer, as a that design engineer, as a consultant engineer, any role, you need to go that kind of that other that after your graduation, this is your basic degree, no? So then after your basic degree, you cannot uh, go for the further. You need to improve your knowledge day by day according to that kind of organizations. You can get that kind of membership, that kind of further that exams you can following for the green building exams and other that kind of exams you can following for, through industry. So then you can gather knowledge and you can get the professional memberships as well in that places. So then you become a engineer to consultant engineer, right? Or that professional, that best engineer from the industry. So then you can get the good that ratings and good things from your under your name, right? So then this is the things. So then uh, any kind of we can talk about some case studies as well for the industry. What kind of things you can find some. I'm also talk about some case studies in as well in my during my this session. But in further things, we can also discuss any kind of questions or any kind of things you need to discuss about further for up to that point. No, any questions or any further things? Are you audible? Okay. So then, no any question means or everything perfect. Uh, yeah. Yeah. Yes. Ye- Yeah. Yes. Yes. Yes, Mandara. Thank you for your question. So then, actually, it's like this. You can use for the your laboratory. I got that same thing in for the chat fact also one highlight for that point also. So then, actually, it's like this. So then, a lot of softwares and Astray also have defined their that designing point for the commercial and industrial building. Astray that they also have some different softwares introduced for the system, like that Astray E20 method. Astray E20 also that we need to that get the our design stages. We need to get the proper idea about how many people also there are, because that actually define each and every points what are the heat load for that particular items and particular things. It like this. If 500 people accommodate for the some factory building, so then each and every head they also have heat load, and it's a defined on the according to work as well, because you know that sometimes that very that if you think about the software engineers that place that have 500 top software engineers in inside that building, but they are not doing the heavy duty work. They are doing only for the that in front of the computer or laptop, and they are doing that kind of work. But a same area, if you accommodate for the that like garment factory or that kind of workers, then they have doing a lot of works. And at the same time, ironing, they are machine operators, iron operators, and that kind of people. According to that cases, have same place, same space, but heat load also different, right? So according to that cases, Astray also that define what is the heat load per person. A normal person, according to his job role, job description, they are mentioned how many heat load generating from the person. It like 450 BTU per person per head, 350 per head, 550 per head, like that. That also have some tables, and according to the same time have according to inside the power how that machine requirements. That mean if they are also available in the carbon the sewing machines. So the sewing machine, what is the heat generation of the sewing machine? That means how many watts you need to think about how many watts about that total power watt available in that inside the building equal to 1 watt 3.14 something BTU hour for heat load for one electrical watt. So then that kind of things you can get the thing. And that kind of initial things you need to gather the your premises, how many people, what are the how many lights available, what are the watts of total light consuming lights, and what are the power consumption, electrical power consumption inside the machines, and what are how many bottle line also they are like that. I'm going for the scenario for the gown factory. They also have bottle lining and that sewing machines and other that Bartek machines and that lot of machine items also there. So then you need to get the what are the how many watts total electric power watts also there, and machine some machines define there what are the heat load of they are generating. At the same time, how many windows also there, that windows facing north side door, that other sides. Then the sunrise. What is the pattern of the sunrise come through windows for the building? And what are the walls? And in that walls also, it's a sandwich panel walls that sometimes construct with the sandwich panel walls, sometimes construct with the cement wall, sometimes construct with the other material wall. What are the wall? What it's a slab wall. It's inside the top of the ceiling with the roof for slab level, no, 3 story, 4 story building, no, like that kind of things. And what are the near places available resources? It's maybe near. It can have that river, that kind of ponto, some that kind of things. So according to all these things, that case studies, you need to gather first your design. So then after Astray also have E20 software, right? Astray E20 also there, and that kind of things also there. So then you can go through that softwares and that same times carry also has their carrier. They are producing some softwares, have that kind of things, and simulation softwares also. That lot of softwares you can find. And now that design stage, initially we are using for the AutoCAD, but now not the AutoCAD only. Now available with the that BIM modeling, Revit, and that lot of new generation softwares also available. So then you can use lot of things in that according to your design calculations. But first, basically, you need about so how to calculate the manual and what are you need to basic idea what are the things what are that the psychometric how the psychometric chart works, how the that basic revision cycle works, equipments, what are the equipments and what are the equipment works. That kind of idea you need to initially definitely as engineer you need to that kind of knowledge. Then after you can further you can that save your time to using for the softwares. There are lot of softwares available. That's okay, no issue. I think you you got that answer, no? And one question available is in our practical, we made some assumption like we consider a small pillar as window in a small room. So a big building, these assumptions are possible. No, actually, that big buildings, we can actually thumb rules is like this. You need to know about the thumb rules as well. But thumb rules, you cannot do the proper design. As a proper design, you need to go with that proper calculations according to that SJ20 or that Bimbolino, that carriers and like that kind of things. You need to that do the proper design after you can verify your design using through thumb rules, right? But that thumb rules you cannot use for the commercial and industrial buildings. it's a that not recommended method, but that after you done your design, you can it's normally we also practicing like that. Sometimes we are doing the calculations in proper way, and after that we are using for the some thumb rules, and we are have get the idea about is that okay or not. But you cannot use thumb rules through your proper designs, right? Okay. Any other questions? Okay, I will go through then some that are very few some that if in a practical scenarios, uh, some some things as engineering practices you need to I will share some knowledges for you. And that most of the that things I'm discussing with your doctor as well in a few days ago. As a engineering professionals, as a engineers, you are graduate after your immediate graduation, you need to do one thing, right? Most because in the industry, you know that past few years in Sri Lanka, we have lot of issues according to after coronaviruses, then that is the attack, then after that economy also going for the clash, then again Argalaya also happening, and that kind of things continuously coming to the industry. Then Sri Lanka also have big trouble for the that new buildings and new projects also not moving. According to that case, we have that all the projects also have Sri Lanka also have that consultant engineers, right? So then consultancy firms they are doing the initial stage for the consultancy and design stage they are doing the design proper designs and everything. So then after implementation stage also consultant also have their role. And same time that vendor that mean that contractor after selecting the contractor also have their own engineers and they are as a team they are doing the project, right? So then but all the initial designs and equipment selection everything depend on consultant design, right? So then Sri Lanka also have very good consultancy team in for the HPC industry, good engineers also available. But we have some facing some problems in past these few past few years. Second layer of the consultancy firms. That mean that we have that a good consultancy more than 50, 55 years, 60 years, that ages, good consultants also available in Sri Lanka. So then second layer like that 40 to 50-year age, second layer good consultancy engineers for the second layer. They are working with that senior consultant and get the knowledge from that consultancy firms. And they also that second also available in Sri Lanka that a few years back. But unfortunately, according to that all the happenings, that most of 90% of the second layers of the consultants consultant engineers, they are migrate with their families according to their scenarios. So then industry again going for the slowly moving, and now that consultancy firms also they have uh, that available vacancies for the engineering professionals. Now we can find in the past few years, lot of immediate pass out engineering students, they are joining that consultancy firms. That's okay. So then after some 1 to 2, 1 to 3 years, they are again for that three four people, three four that engineers, they come out from that their consultancy firm and they started new consultancy company or some new consultancy firm. So then, but they have not gathered good knowledge. They have not gathered that standard or practicing or anything. But now they are have doing the that prepare the BOQs and other things, and they also have that if consultancy firm that senior consultancy firm they are charging for that project 5 million. That new that kind of consultancy firms they are charging for 5 lakhs 1 million for that project. and they are trying to get the projects. But initially stage, sometimes we facing these problems in industry. Then they have not lack of they have very lack of knowledge of the industry practices and everything, because they have not practicing well with their that career life. So then after project also going for the collapse, contractors cannot do the proper job, and lot of things happening. And after that, some one or two, three projects, that engineering, that consultants firm or that engineers also uh, automatically their names also going for the bad list. So then my personal advice is, after your graduation, first, you go with the some good contracting firm or that premises building like that, hotels or supermarket or supermall, also like that kind of premises for the that engineering professionals to their engineering teams. You join with that kind of places or contracting companies. So then 2 3 years at least you can work with that places and you can gather the practical knowledge. What are the equipments? What are the things? What kind of items available? What are the practical that problems you have facing? How you can work with your top management and your middle management and your service providers. So then, how they are handling? What are the that skills you need to handle with your contracting people or your that service providers, and how you get maintain the pressure with your immediate that management, how you can handle for that kind of things. So then after some certain years, you can get that proper knowledge. You can join with the consultancy firm under super consultant. So then you can be definitely within a very shorter time period, you can become a good consultant engineer or good practitioner, right? So then think about that as well. And then some, because I will show you, I will that one case. So then uh, one customer, one that reputed hotel in Sri Lanka, I cannot tell the name. That hotel also called me one day, and that their chief engineer, he asked me to, Rosanta, if you have time, can you come to our hotel? We have a big problem in our kitchen. So then I'm asking what is this? So then he told that big complaint from our that chef for they cannot uh, doing the proper cooking. So then have big issue. So then can you come and looking for what is the case? So then I'm going for that place. So then I'm going for that place, and I'm that initially I'm some small chat with the chef, and he told Rasanta, we cannot cooking well because that uh, if you trying to use the cooks, sometimes we put our that small items like the karapincha and other that kind of items. We put that our our cooking time. It not throw out to your that cooking pot. It going through canopy filter, right? What is the scenario? That means that extraction capacity also very high capacity designed for that extraction capacity, and unnecessary capacity fan also installed that cooker hood, accommodated to that cooker hood, and chefs they cannot that using their proper way to cooking. So then that if we said he said මේ සිංහල ලසන්ත මම කරමින්ච ටික මගේ මේකට දානකොට පොයි මේ මම මගේ පරිප්පයකට කරමින්ච දානවා කරමින්චේ පරිප්පයට එන්නේ නැහැ කිව්වා ගිහිල්ලා උඩට ගිහිල්ලා ඉවරලා උඩ තියෙන ෆිල්ටරේ තමයි කරමින්ච ටික රැඳෙන්නේ ඒකට එක්ස්ට්‍රැක්ට් කරනවා. So then it's a very that a funny thing. So then I'm going for the fan side, and I'm check with the fan capacities and according to his hood size and according to the fan capacity. So then it's a totally wrong selection. So then I'm discussing with the chief engineer who is the done this who is the contractor who's the doing the things. So then he give me that contractor name, and so then I discuss with contractor why you selecting for this fan or what other things because that fan also have at the moment that time also guarantee as well. So that warranty period also they are. So then we cannot, that according to warranty period, if you do something, some modification for that system, so then client cannot grant the warranty about that equipment. So then I'm not doing anything about that thing, and I discuss with the contractor to I call and ask for contractor to do the modification, and I told him that fans capacity and everything also wrong. So then, can you do that? Can you control the things for doing some replace the low capacity fan? No, otherwise you can doing some dampers to control the airflow and like that kind of things. So then he told that we can do that, but we need to do the extra charges. So then that a client not agree to pay extra charges because he told we cannot do extra charges pay you because you are the contractor and you need to you doing this bullshit. But root case also not for the contractor for the tender document. Tender document also mentioned this is the capacity of the fan. This is the things. This is the things. Tender document done for the one of some new consultant, and he also don't know about that kind of he is not doing good experience about that things. He get the some same scenario case study. He get the tender document from previous some places, and he will get that fan thing and copy and paste for his document. So then, according to this place, the kitchen area also the same like Iska food or some area also the same. But his get that document that place also have 5 6 canopies and connecting to the one fan. Then that capacity also okay for that. But this place have only 1 or 2 canopies. So then don't know into that much of capacity. But he thought about this area about this. So then we can accommodate this fan for this ventilation. So then it's a totally wrong and have that a big problem according to that final that vendor. So then after that, agree with all the people that then consultant also not responsible and he's not responsible about the things as well. So then again, client agree to pay some small amount to contractor and doing the corrections and do the things after that and correct the things. So then that's the some that one case for that I can share with you. And again another case that that one I told you that hospital also we have some in it's like this that you have to maintain very well in your equipment frequency maintenance as well. You know that in 19 after First World War, I cannot remember the year, after First World War or Second World War time, that the USA, one army regiment, there's a very that common case in industry. So then one army regiment, they have that old people, they are serve their country to wartime, and now they have every and they have gathering for the every year for their army that platoon, right? So then one hotel, they have so 50 or 60 people gathering for that army platoon in a one control room. So then after that party, that people also have different places in USA, some also in Texas, some also in New Jersey, some also in New York, like that places. But they came to that party for same place, and same banquet hall they have that party. After that party, they also going their hometowns. So then, uh, then they have get the message some after a few days, one or two that they are that people also going for the diet. So then after another 2 3 days, again two three people going for the diet. Some also have some incidents and they are admitted to the hospital, like that kind of things. So then they have that their group also they have think about that all the people also have same kind of that symptoms. They also that according to their death, so there are that cases. So then doctors going for the root case. What is the root case? Why this same that this team have this issue? What is the root case? Then they are going for the root case and they are finding they all the met same place in few weeks ago in a some hotel. So then they are going for that hotel. So then they are going for that hotel and they are check that they are they are gathering that banquet hall or some that kind of place. They are check the things. So then they cannot find the any that of food poison or any kind of things that food and everything also perfect. So, but then they are checking the indoor air quality of the that place because that air conditioning room, indoor air quality of the that place. So then they find that indoor air quality also have some different some bacteria or virus. So then they are going for their air handling unit and check the air handling unit and that cooling towers and that equipment. So then cooling tower, the air handling unit supply air duct, that makeup air duct also available with the near the cooling tower, right? Near the cooling tower area, that also duct line, it connect to the get the fresh air to air handling unit. So then cooling tower, they are not proper maintaining, proper servicing, frequent services, they are not done. Then cooling tower, what also have reusable long time, and they also have some fungus and that some bacteria growth for that cooling tower. That bacteria going through that fresh air duct system that they are sucking to fresh air for a air handling unit. So that bacteria go for that duct and it come to the air handling unit and it come to that room. So that bacteria also infected that people and 10, 15 people also already going for the diet. I share that case for you. So then, that if you think about, you are not doctors, no, you are engineers. So then, but doctors also can save the life, and sometimes some mistakes. Doctors also have some mistakes. Some people also going die. But that's a one or two people, according to that mistake, going die for one time, one person, right? But if you are an engineer, if you are doing that kind of not preventive maintenance or that kind of things and proper equipment selection, proper that filtration selections, that kind of things you are negligible and you are not doing well, then one time you have died for several peoples. Doctor can doing one mistake and can one die for the one person. But if you're doing as an engineer, professional engineer, if you're doing that kind of bullshit, definitely it happened to the many people. So then you have big role to the industry. After you come to the industry as engineers, you have lot of big role to do and the same time as an engineer, if you are doing that that as a if you think about it as engineers also all the engineers know if you're doing some that wrong selection of the electrical wire. So then you if you do the approval for the wrong wire gauge and that equipment, your chiller also consuming high power. But as an engineer, you not check about the that supply wire thickness, copper thickness and wire gauge and everything. You not check about that. So then that wire come to the inside the wall through your plant room. So then your chiller consuming high capacity, high power. So then that wire also cannot accommodate for that kind of capacity. So then wire going for the damage, and it also go for the power leakage through building. Then building 100% immediately building can be going for the that according to wire things, you know that most of the buildings that are going for that fire that things happen for the wiring system, no? So then finally, if you go for the root case, that responsible for that issue as a selecting for the wire or wrong pattern according to not suitable wires to according to your unit capacities, that responsible for the engineer. So then, but most of the people inside the building can be vanished 5 10 minutes. So then you have big role, big responsibility according to that kind of things. So then keep in mind as well, if you come to the practical engineer after your graduation, you definitely think about that kind of things, and as a practice as well. And day by day, you go with the that day by day. Now world also going changed. So then everything also happening that day by day moderate. So then you go with your social media, you consume more time with the social media, Facebook, TikTok, and other that kind of things. You use for that time for that gather what are the knowledge, get the knowledge for engineering that things. That also that what kind of things are day by day changing world? What are the your the modules? What are the upgradations available? You use for your time for that as well. So that's the things I need to talk about according to that some cases, and like that. I think you have that about a good idea. What is your job role, and how much weight available for your job? I think you can get some small idea about that as well. So anything else? If you have any questions or anything, or we can now complete our session. If you want that any further details or any kind of things, I can share my contact number as well to you. My number is I can write down in a chat box. This is my contact number. If you have any kind of that further questions or any further that after you come to the industry, some job, if you want to find some jobs or any kind of things, or astray, some astray standards, so any astray, how to get the astray memberships, astray, that kind of things, or any kind of things, you can contact me. But at the moment, I'm in a Maldives, and I will back to Sri Lanka in 24th in this month again. Or you can send me that small message through WhatsApp as well. So then I can respond according to that, right? Anything else? Or we can complete the session. Are you audible?
Yes, sir. We can't see the contact number here, sir.
Okay. I send. Okay, you can write down the contact number. Note 773 741 781.
Thank you,
Is it
sir.
okay? Note 773 741 781. Okay.
Okay, sir.
Okay. That I think now everything. I think that I completed my session. So then, anything else you can contact me as well. So then, thank you for participating in the lesson. And I wish you all the best to all of you in your future life as an engineer, and be a good engineer to industry. So then, you have a big role to industry. So then, welcome to the engineering industry in future as well. And wish you all the best to all of you to come to industry as a good engineers.
Excuse me.
Yes.
So on behalf of everyone, I would like to sincerely thank you, sir, for today's session on HVAC systems. And you explained the concepts in such a clear and practical manner. And the real world examples you shared greatly helped us to understand how these systems function in actual applications, sir. We truly appreciate your time, sir, and the effort you took to share your valuable knowledge with us. It was indeed a very useful and insightful session for all of us, sir. So thank you once again, sir. We are truly grateful for this opportunity to learn from you, sir. Thank you.
Okay. Thank you very much. Thank you. Okay.